Okay, I'm just going to put a few examples up here on this board, and it's just a review for what your next problem evaluation would be, and that's naming compounds and then in certain cases adding together their atomic masses. So this is how we actually had started this chapter if we had, for instance, this lithium, we'll just say bromide. Okay. So what you're going to want to do is start with what is the symbol for lithium, and that is Li, and the symbol for the bromide ion, notice doesn't say lithium bromine, so Br, okay? And think about, we always said start with which charge, okay? And that would be the negative charge, that's -1, lithium being in column 1, as a +1 charge, those add up to 0. So we got a 0 net charge, so that has to be correct. So if we move on and do an element that's in the same column, but maybe, for instance, we do something like this. Potassium, we'll say sulfide. Okay, so notice that we don't have a Roman numeral in there. The only time that you're using a Roman numeral is if it has more than one positive charge. It could be a charge of +2 or +3 or +2 or +4. That's when you're using Roman numerals. But potassium and lithium only have one type of charge because it's in column 1, so it only has a charge of +1. So in this case, again, symbol for potassium is K. The symbol for the sulfide ion is just S. Okay, so if we have K and S, go by our charges, and we've got -2 here, +1 there. The least common multiple between 1 and 2 is 2. 2 divided by 2 gives you 1, and we've got 1, and 2 divided by 1 would give you 2. So K2S. Okay. Now, once we start putting polyatomic ions in there, for instance, we could do, let's do potassium. We'll just say carbonate. Okay, so in this case, again, write down what the symbol is for these elements. We've already established that the potassium is K, and then this is not a monoatomic ion like sulfur to sulfide, bromine to bromide. Carbonate is a polyatomic ion, and that charge is CO3, and it's got a -2 charge. And potassium will not change without a lithium. It's got a +1 charge. So what we see happening here is the least common multiple again is 2, and 2 divided by 2 is 1, and we've got 1 carbonate ion. 2 divided by 1 gives you 2, so we've got K2CO3, potassium carbonate. Okay, so then in certain cases, perhaps you have to add together the atomic masses of these compounds. So if that's the case, okay, every potassium has approximately 39.1 grams. Let me just grab a periodic table here quickly. Potassium, 39.1. And we've got 2 of those, so you could just add together another 39.1, or you can take it times 2, which I'm going to take that number times 2. That gives you 78.2. All right, carbon is 12.01, so we're going to add 78.2 plus 12.01, and 1 oxygen atom is 16, but we've got 3 of them. 16 times 3 would give you 48. So once we add those together, 78.2 for your potassiums, 12.01 for your carbon, and then 48 for your oxygens, and that gives us a total of 138, I think. Yes, 138.21 for potassium carbonate. Okay, so I'll go ahead. If you need this, to want to review these, just go ahead and hit pause at this time, because I'm going to do the same and then go ahead and erase these. Okay, so I have 3 examples up here. Now, we see the formula, we're going to write out the name, okay? Because here we have the name, you'd write out the formula. All right, so in this case, Pb is the symbol for lead. And this is a monoatomic ion. That's a polyatomic ion, and so is that, okay? So in this case, we've got lead, and then Cl is chloride. Okay, even though lead is not a D block element, I don't believe, no, it's in the P block, but yet it has more than one charge. So this again is why we go by your negative ion. Chloride has a charge of -1, and you've got 2 of them, okay? So if that's the case, your chlorides have a charge of -2. We only have 1 of these leads, so that means this is going to be lead 2 chloride. Because if it was lead 4, well then we would have this instead. Okay, then you'd have lead 4 chloride, because then all your negative charges would be -4, and this would be +4 then. But we had it as 2 here, so lead 2 chloride. Again, that's the only time that you use these Roman numerals, if an element has more than one charge. You don't do that for elements in column 1. You don't do it for elements in column 2, because like potassium only has a charge of +1. Magnesium and calcium only have a charge of +2. Aluminum only has a charge of +3. Okay? But lead has 2 different charges, and of course nickel has 2 different charges. It's either +2 or +3. So we're telling you what that is, that this has that of a charge of +3. Okay? So if we needed to add those together, okay, lead, let's see here, my calculator, all right, is 207, I believe. And again, you students will probably, by the time you're done with general chemistry, will probably have a lot of these numbers memorized, not because you were forced to, but because you're possibly using these over and over again. So lead, 207, okay, and chloride, or chlorine, but if you're talking about chlorine, but when it's a neutral element, but here it's chloride, so every chloride is 35.45, and you can just write that twice because we've got 2 of them. Okay, so 70.90, that's what happens when you double these, then plus 207, and that would give you 277.9. And that's the atomic mass for lead 2 chloride. All right, then we move on to, for instance, we could go down to, no, let's just go ahead and keep these going in order. Okay, so nickel has a symbol of Ni, and sulfate, okay, what's the formula for sulfate? Well, it's down here. It's got that of SO4, and one of the things, go by the negative charge, and that is sulfate, which has a charge of -2, okay? And nickel, we don't have to guess, it's telling us it's +3. Notice that does not add up to 0, so the least common multiple between 3 and 2 is 6. Right now we've got 1 nickel atom and we've got 1 sulfate atom, okay? So the least common multiple is 6. If we divide 6 by 2, that gives us 3. So we need 3 sulfate atoms, or sulfate ions. So once you do that, okay, that's the answer that you get when you divide those, 6 divided by 2 gives you 3, but we want 3 sulfate ions, not 43 oxygens. So therefore, this has to go in parentheses. Okay? And then the answer we get here, 6 divided by 3, gives you 2. Okay? So that's how you'd write out the formula for nickel 2 sulfate. All right? Then if we're going to add those together, okay, you can have your periodic table. Nickel is 58.69, and we're going to take that times 2. Okay, and then we've got 3 sulfur atoms because we have to distribute that 3. So 32.06 times 3, that gives you 96.18 for all your sulfur atoms. Now our oxygen atoms, we've got 12 of them. So 12 times 16, because the atomic mass for oxygen is 16, and we've got 12 of them. By distributing that, that gives us 192 for your oxygens, plus the 96.18 for your sulfurs, and then plus 117.38 for your nickels. And then that gives us 405.56. 405.56. Okay? And then we'll just do this last one, and then that will be it for today. All right. So this is the only positive polyatomic ion that you are responsible for, and it's got a charge of +1. Sulfate, as we did up here, has a charge of -2. Okay, that's why the least common multiple between 1 and 2 is 2. 2 divided by 2 gives you 1. That's 1 sulfate ion. 2 divided by 1 gives you 2, and that's why that 2 is on the outside of the parentheses. So how would we go about adding this one together? This 2 has to be distributed through the entire molecule, if you want to call it that, or entire formula for ammonium. Ammonium sulfate. And then to add those together, 1 nitrogen is 14.01 times 2 gives you 28.02. And then 1 hydrogen is 1.01, but we've got 8 of them, so we're going to add 8.08. Okay. And then 1 sulfur atom is 32.06. Okay. And then 1 oxygen is 16. 16 times 4 would give you 64. So we're going to add that on to the end. Therefore, that gives us 132.16. All right. So that's an example of what your part 2 of your problem evaluation will be like. There's, I think, 2 sides to it. The front side, you're just naming compounds, okay, like this. Or if you see the formula, you got to write it out. Then on the back side, you got to write it out and add together the atomic masses, because this does take a little bit of time. That's why you're not doing that on both sides. And then when it comes to, do you get to have these polyatomic ions? Well, no, because if you have sulfate wrote out here in another compound, you have SO4. We know what the formula is for sulfate, because sulfate has sulfur in it. So in other words, here's sulfate. We did carbonate earlier, so it's got to have carbon in it. Okay, and then if it's nitrate, that's going to have nitrogen in it. And then hydroxide is this. And then phosphate has phosphorus in it. So that's PO4 then. Okay, and then we discussed your only positive charged one is NH4. So in this case, these two, okay, -1, these two, -2, this one, -3, and then this one, +1. Okay, so we're about up to 15 minutes, and that's where we like to try to keep these. So that's all I have. Remember, if we're in session tomorrow, we will have your problem evaluation over naming these compounds. If we don't have class tomorrow, well then this will be on Monday. All right, thanks for tuning in, and we'll catch up to you next time.